All right, so here we go. So anyway, back to business. So our goal here is to be able to convert from standard form to vertex form, right? That's the whole point of this. So we want to be able to do problems like this, like convert x squared plus 6x plus 5 to vertex form by completing the square. Okay, that's the goal for the day, is to get to that point. Okay, but to get there, we need to do just a little bit of brief review because it makes it easier to understand if you put this in the context of factoring. So we got to go back to Algebra 1, and you would have done just tons of these problems. Like if you're given a simple quadratic trinomial, so it's got three terms, got an x squared term, an x term, and a constant. You know, it's in the form ax squared plus bx plus c, where a is equal to 1. Then factoring's pretty easy. Factoring is it's the opposite of multiplying. It's when we want to take something, we want to break it up into a product of smaller pieces. So for example, we know that if I have, for example, 2 times 3 equals 6, right? Well, that process is, you've been doing that for a long time. That's called multiplying. But if I were to reverse that and start with the 6 and work backwards and turn it into a 2 times 3, that's called factoring. We're going to write something as a product of factors, okay? So if we want to do that with something algebraic like this, where it's not just numbers, it's like we're unfoiling, right? You want to figure out what are the two things I would multiply together to get this trinomial. Well, each of these little pieces is going to be a binomial. It's going to be well, we know what the first term of each of those factors is going to be. It's going to be an x. It has to be. Because if I were going to distribute, to multiply this thing out, what would I distribute? What times what is going to give me an x squared? X times x, right? So you know that has to be an x and that has to be an x. Okay, but the question is, what are the magic numbers that go with the x's to make all this other stuff happen, right? And so this is where we kind of go back and review from Algebra 1 a little bit. The magic numbers have to do two things. They have to multiply to c, and they have to add to b, right? So what would the numbers be here? What are the values of a, b, and c in this trinomial? 1. So we got to multiply to 5 and add to 6, right? What two numbers multiply to 5 and add to 6?
Add to 5 and multiply to 6.
No, multiply to 5 and add to 6. 1 and 5. Yeah, 1 and 5. So the numbers would be 1 and 5, and we can show that it works, right? Like, what if I want to check it by multiplying? Just see if I go the other direction. If I multiply these out, do I get x squared plus 6x plus 5? So we could distribute the x, right? If I distribute the x, I'm going to get x squared plus 5x. If I distribute the 1, I'm going to get 1 times x is x plus 5. And if I add up all those like terms, what do I get? I get that, don't I? So it works. Right? Remember doing this?
No.
Well, you did it about 1,000 times probably in Algebra 1. You would have done tons and tons of this degree. So what about this guy here then? So let's try factoring this one. And if you don't remember doing it, it's okay. It's not hard to do. And this really isn't the topic of the day. We're going to go back and review this in more detail in Unit 4. And I just want to just touch on it very briefly today. So if you're not feeling great about this, don't panic. We're going to talk about this more soon. Okay? How about this one? A is equal to 1. So if I want to break this apart into factors, I know I'm going to have an x and an x because I have an x squared there. Now, what would the magic numbers be this time? They have to multiply to what?
32.
To negative 32. And they have to add to negative 4. So now you just got to think for a while here. What numbers would multiply to negative 32 and add to negative 4? Okay, but what are the signs? You have to be careful about the signs. Negative 8 and positive 4. Okay. Okay, wouldn't that work? -8 times +4 is -32, and -8 plus +4 is -4. And if that's not just leaping to your mind, that's okay. I'm gonna give you some tricks for coming up with those numbers next unit, okay? But here's why I wanted to, here's the whole point of why I'm reviewing this. This is a special example. Let's look at this special example here. And this time, I want you to tell me, what are the magic numbers? They multiply to what? Okay, so which is 16, right? And they add to 8. So what numbers multiply to 16 and add to 8? 4 and 4, okay. Now, they're the same magic number. That's what's important about this example. So that's equal to x plus 4. How would I write that if it's x plus 4 times x plus 4?
X plus 4 squared.
Squared. Okay. So this was a special trinomial because this time, of all the 3 examples we did, this one was unique because the magic numbers were the same number, right? And so because that happened, we call this third example, this trinomial is a perfect square trinomial because it gave us, when we factored it, it gave us a perfect square. Perfect square factor, right? Same factor times itself, okay? This is important to us because think about the process that we're trying to do here. If we're trying to go from our goal here, right? The goal of the day is we want to start off with standard form, which is ax squared plus bx plus c, and we want to convert that into vertex form, right? Which is a times the quantity x minus h squared plus k. Well, why do you think that last example is so important? Because look, there's a perfect square factor in vertex form, isn't there? I end up with x minus h quantity squared, right? So if I were to multiply that out, wouldn't I have to get a perfect square trinomial from that? Right? Because I have one single factor times itself, right? So do you see a pattern here? If we go back and look at this last example, it's only one example, so you can't always just say, okay, the pattern's going to always work, but it will. What's the relationship between the magic number that we got and B and C? The magic number 4 that we ended up getting out of this thing was equal to half of B, wasn't it? Everybody see that? And C was equal to half of B squared. That's always going to work. Every time you're going to see that relationship, right? So when we talk about perfect square trinomials are trinomials where there's the relationship where b over 2 squared is equal to c. So when we look at these, that's the case for each one of these. Isn't that the case? Right? Look, b is 4, or b is 8, right? So b over 2, meaning just half of b is 4, agreed?
Yeah.
So half of b squared is 16. A is, or sorry, I'm sorry, here b is 2, right? So half of b is 1, 1 squared is 1. What's b here? Negative 18. What's half of negative 18? Negative 9. Okay, so b over 2 is negative 9. Negative 9 squared is 81. What do you know? So that's also a perfect square trinomial. Half of negative 10 is negative 5. Squared is positive 25, right? So if I factor all of these, they're super easy to factor because they fit that pattern. This is my magic number here is just going to be 4 and 4, isn't it? Right? The magic numbers that multiply to 16 and add to 8 are 4 and 4. So I just write it as x plus 4 squared. Okay? What about down here? What's the magic number going to be here that gets repeated? Multiplies to 1 and adds to 2. 1. And we know it's 1 because it's got to be half of b. without even thinking about it here, if we know that's a perfect square trinomial, isn't it just gonna be half of negative 18 is negative 9? So the magic number's gotta be negative 9. And it does work, right, because that's an 81. This one's gonna be a negative 5, isn't it? Okay? So here's a really cool way that you can represent this visually, using shapes. Okay? Phones should all be away, please. I'm gonna put them like in your pockets away. You gotta get this stuff, or there's not much time left, right? I mean, we got next week and that's it. So here's a cool way to see this visually. Now, would you agree that if I've got this trinomial, if I want to represent it as a bunch of areas, I've got 3 terms added up. Let's represent each one of those terms as an area. Well, x squared, that's just the area, isn't that the area of a square that has a side length of x? Because how do you find the area of a square? You just do the side length of a square squared, right? Okay. So then that works if that's an x and that's an x, right? Then the area of that square is x squared. Okay. Well, what about this rectangle here? 8 times x. You get the area of a rectangle by multiplying length times width, don't you? Right? Well, we know that this rectangle has the same height as that square, so that dimension is x. What must that dimension be if the area is going to be 8x? Got to be 8, doesn't it? And then, length times width, I end up getting 8x for the area of the rectangle. Okay. Now, what about that little itty bitty square over there? If that's 8, this is half the width of that one, right? So this one is going to be 4 times 4, which is 16. Okay? Everybody agree? Okay? Now, it's hard to see that way, but that's a perfect square trinomial, isn't it? So I should be able to write that as a factor squared. And you can already tell me, well, we already did it. It's right up there. It's x plus 4 squared, isn't it? So then wouldn't you agree that if I were to reconfigure that area and cut and paste a little bit, I should be able to create a single square that has a side length of x plus 4? Right? Because something, side length squared gives us the area of a square. Well, we can do that. Watch. If I split that big rectangle into 2 pieces, and I'm just going to reconfigure this thing a little bit. I'm going to take this piece right here, that piece right there, come on now, that piece right there we go, and I'm going to slide him over, like so. I'm going to take this piece, and let's rotate that one. Right? And then that piece right there, we'll just stick down in the corner. And what do you know? Look at that. How about that? How about that? Now you tell me, based on this picture up here, what's going to be the width of that square? It's x plus 4, because didn't we cut that thing in half? Right? So it's x plus 4 times, what's the height? X plus 4, right? So sure enough, we get our x plus 4 squared. Right? Okay? So now the trick with completing the square is, it's almost the same process, but when we're completing the square, the goal is to take 2 terms, x squared plus bx, where b is just some number, right? And we want to figure out, okay, in order to turn that into a perfect square trinomial, what other little number would I have to add to complete the square? Now, if we do the same process, if we cut this, we got these 2 areas, if we cut this rectangle into 2 pieces, wouldn't each of the individual pieces, it's still going to be x tall, but it's only going to be half of b wide, agreed? So the dimensions would be b over 2 times x, right? And if I push those all together, it almost makes a square. right? But we've got this one little chunk that's still carved out of the bottom corner. In order to complete the square, meaning to turn it into a complete square, I would have to add that one additional little piece down there, wouldn't I? What are the dimensions of that piece going to be? B over 2 times B over 2, so B over 2 squared. Agreed? So there's the additional piece I have to add to what I started with, which was just those two pieces, in order to complete the square, right? That's the whole trick. That's the whole trick, right? So the whole purpose here is, if we start off with something that looks like x squared plus bx, and I want to create a perfect square trinomial, I already know what to do. I just add half of b squared to those two terms, and I create a perfect square trinomial. X plus b over 2 quantity squared, right? Okay, why is big deal, right? Well, here's the big deal. If I want to convert this into vertex form, here's how I can do it. If I want to get it into vertex form, remember that I'm going to have to make it look like this, so I'm going to have to create a perfect square, right? Well, to create a perfect square, all we have to do is just start with those two terms, x squared plus 6x, and figure out what's the size of the little piece I have to add to those to create a perfect square trinomial, right? So what would the steps be then? And these are the steps on your notes. They show up down here, the part where it says converting standard form to vertex form. We're just going to go through these 5 steps. So let's look at them in the context of this problem up here. Step 1 is always going to be set it equal to y, right? And there's a reason for that. If it starts off as an f of x, turn it into a y because it's easier to write. It's less confusing, right? If there isn't anything up there to begin with, that's okay. We're going to set it equal to y because we need a place to push all the garbage push all the junk that we're going to get rid of from the right side of the equation when we're completing the square on the right side, and that's what we're going to do. So the first step is really simple. Write it as an equation, set equal to y. Okay, now the next step is a big one. The next step is the one where, using algebra, we want to get the right side of the equation, which is the working side of the equation, where all the action is going to happen. We want to get that to look like x squared plus bx. So we got to get rid of anything that's complicating that, right? So in this case, we got to get rid of the 5, don't we? Right? Because what is the value of b right now? 6. Okay, so I've got x squared plus 6x would be great, but I got to get rid of the 5. And so we're going to subtract 5 from both sides. Okay, now the right side looks like what we need it to look like, doesn't it? The right side looks like x squared plus bx. Okay, well then we can now complete the square, right? If b is 6, then the little extra bit that I have to add is going to be half of b squared. We're going to add half of b squared to both sides. Well, b is 6, so b over 2 is 3, right? So b over 2 squared is just 3 squared. So if I add 3 squared, which is just 9, to both sides, don't I end up with, on the right side, this is the same thing as saying x squared plus 6x plus 9, right? Everybody agree? What's that going to factor into? What are the magic numbers going to be? Then multiply to 9 and add to 6? 3 and 3. We already knew that, though. It's going to be that. That's going to be... That's always going to be the double magic number, is half of b, every time, b over 2. Okay, so I already know on the right side of the equation, when I factor this thing, I already know what I'm going to get. This is going to factor into an x plus 3 squared, right? Because my magic numbers are 3 and 3. Okay? But we got to know what's going on the other side of the equation. So how did I get that to be an x plus 3 squared? I had to complete the square by adding 9 to both sides. Everybody get that? I didn't have that there initially. I had x squared plus 6x. So if I add 3 squared to both sides, I get just what I want on the right side, so it factors into a perfect square. I get a perfect square trinomial, which factors into a perfect square. On the left side, what do I get? Well, what's y minus 5 plus 9? y plus 4, right?
That's what I was thinking.
Everybody, you see what I'm saying? I can just simplify the left side. And then now, the only thing I have to do, if we go back to the beginning, we're trying to turn x squared plus 6x plus 5 into vertex form. Well, that's what we call y, isn't it? Y is equal to the thing that we're trying to convert. And so what do you think I need to do now? Do I have a y on the left side? I mean, I got y plus 4. I need to have just a plain old y, because that's what I started with, right? So what do? Subtract 4. Yeah, the last step is I'm just going to undo everything I did, reverse all the stuff I did in steps 2 and 3 to get the y by itself, to isolate the y on the left. So the very last step would just be to subtract 4 from both sides, and voila, I've got it. That's vertex form, isn't it? Right, so there's my answer. Okay, so let's just rehash those steps again, because it's a lot of, when you talk through each step individually, it seems like a lot of stuff, but we didn't do very much. All we did was we set it equal to y. We had to do some algebra to get the right side to look like x squared plus bx, so I had to subtract the 5 away, push that over to the left to get rid of it. Once I got x squared plus 6x, in order to create a perfect square trinomial on the right side, I add half of b squared to both sides, right? Which is going to give me an x plus 4 on the left side, and on the right side, the reason I add that 9 is so that it factors perfectly. So I get the same magic number twice, and then all I got to do is just isolate the y. Subtract that 4 from both sides again, and I'm done. Okay? The nice thing about this is, like when I'm subtracting the 4, you might be thinking, oh my gosh, how am I going to do that with this? You don't. This is just like one big thing that you don't touch. It's a quantity being squared, so when you subtract 4, you just subtract it outside of that, right? Separate. Okay? Try one of these. So here's the next step. Do you want to do one as a class first, before you get on the boards?
No, straight to the boards.
You want it?
Straight to the boards.
Straight to the boards? You really think so?
I think, practice makes perfect.
Mackenzie, what do you think? I trust you. What do you think? You want to go through one with the class first, or go right to the board? Yeah, let's go through. I think we should. I think we should. So before we do that, let's do one of these. Okay, let's try this. How about if we want to convert f of x equals x squared minus 20x plus 96 to vertex form. Right, so we have to complete the square. Okay, Gabe, what's step 1? You can look at your cheat sheet if you want. You got the notes right there. What's step 1?
Convert it to y equals.
Set it equal to y. Right. So step 1, we're going to write this as y instead of f of x. Y equals x squared minus 20x plus 96. Step 2.
Use algebra, make the right side of the equation look like x2 plus bx.
X squared plus bx.
Yeah.
So we just need the x squared term and the x term on the right side, and everything else we're going to get rid of. So what's that mean?
Yeah.
Subtract 96. Exactly, I'm going to subtract 96. So the goal here is I need to make this thing, the right side needs to look like x squared plus bx. So all we got to do is we're just going to subtract 96 from both sides, right? And that's going to give us y minus 96 equals x squared minus 20x. Okay? Step 3. What am I going to do? I gotta create a perfect square trinomial, right?
Yeah.
So I'm gonna have to add something to both sides. I gotta complete the square by adding just the right number to both sides. Yeah, okay. So what's b? Negative 20, right? Okay, so if b is negative 20, b over 2 is what? Negative 10. So that's what I have to add to both sides, negative 10 squared. Right? Which is just 100, isn't it? Okay. So then step 4, we're going to factor. So what am I going to get on this side then? I mean, these two steps go together. I could have known the answer before I ever even put that number in there. Didn't I know I was going to get x plus what number squared? What was my magic number going to be on the right side? Guaranteed. If I complete the square. Negative 10. Right? That's got to be my magic number. Right? So I know I'm going to get x minus 10 squared. But to get there, I had to add that number to both sides to create the perfect square trinomial. Right? So on the right side, I've got my perfect square, but on the left side, what do I have? I have y minus 96 plus 100. What's that? Yeah, that's just right. That's the same thing as saying y minus 96 plus 100. So negative 4? Positive 4. So I'm going to get y plus 4, right? And now last step. Subtract 4. There you go, right? Just got to get the y by itself. Isolate y. So we're just going to get y equals all this stuff minus 4. Right? You guys can do that, right? Absolutely. Okay, so try it.
To the boards.
To the boards. Okay, so let's zip through our steps here real quick, right? Step 1, we're going to write it as a y, correct? Step 2.
Subtract C.
Subtract c, so we got to get rid of that 18. So we'll subtract 18 to the other side. So y minus 18 equals x squared minus 8x. Okay, now we know that we're going to add the same thing to both sides so that I create a perfect square trinomial, right? You already know what the answer is going to be on the right side, though, don't you?
Yes.
You already know that after I add that magic number over there, that it's a magic number squared, actually, isn't it? Down here, I'm going to end up getting what?
Minus.
Yeah, minus 4, right? Because we know b is negative 8, so b over 2 is negative 4, isn't it?
Yeah.
So then you automatically know that that's going to be a negative 4. Okay, but to make that happen, what did I have to add to both sides? 16. I had to add negative 4 squared, right? Negative 4 squared equals 16. So I'm adding 16 to both sides, which means on the left side, what do I end up with? Y minus 18 plus 16 is y minus 2, right? So now all I got to do is add 2 to both sides. Y equals the quantity x minus 4 squared plus 2. And doesn't that match a times x minus h squared plus k? What's a?
1.
1. And we knew that from the beginning, didn't we? That a was 1. Right? But more importantly, what are h and k? H is 4, right? And k is?
Got it.
Okay, so you might have already seen that we could have done this problem without completing the square, couldn't we?
Yeah.
Right? We could have done this using our tricks to go from standard, to graph a function in standard form. Think what we did, and we'll talk more about this next time we hit this stuff, but to find the x coordinate of the vertex, what was our little formula? Wasn't it negative b over 2a? Right? So we could have legally cheated on this one, and we could have said h, which is the x coordinate of the vertex, is always negative b over 2a. Well, look, if I go back here, a is 1, b is negative 8, c is 18, right? So negative b over 2a would have just given us positive 8 over 2, which is 4. What do you know? Right? And k is the y coordinate that goes with h. So isn't that just always going to be f of h? So in this case, it would have been f of 4. If I plugged 4 into the original function, if I plug 4 into the original function, look what I would have gotten. F of 4 would have been 4 squared minus 8 times 4 plus 18. I guarantee if you do all that stuff, you get 2. 16 plus 18 is 34 minus 32, right?
Yeah.
So we could have done this without even completing the square, but I think you'll find completing the squares faster. Once you get good at it.
What?